My name is Okwe Janicio, and this is my slideshow on the chemistry behind hand warmers. This is going to include my demo instructions and materials, as well as some other facts about hand warmers. So first, for your equipment, what you're going to need is a 2-pack of hand warmers, a lab quest, a temperature probe, and a laptop. And the steps that you're going to take are: first, you're going to turn on your lab quest and make sure that the temperature probe is working and at room temperature. The reason you want it at room temperature is just so that it doesn't start off too hot or too cold, and that could mess up your data. And the second step is, once the lab quest is hooked up and the temperature probe is working, take the hand warmer out of its packaging, and then, third step, tape the temperature probe to the hand warmer and let it sit for about 10 to 15 minutes. And 10 to 15 minutes is around like the good time you want for the hand warmer to pretty much reach its peak temperature. And then step 4, after 10 to 15 minutes, remove the temperature probe from the hand warmer and collect the data. And the big question is, how can something produce heat without the use of any flames or electricity? And here is the science behind how the hand warmer operates and works. There are 5 active ingredients in a single hand warmer packet. The first 2 you know pretty well: water and salt, and the next 3 you might not be as familiar with: iron powder, vermiculite, and activated charcoal powder. What these 3 do is, the iron powder acts as the agent that is used to create the rust when the oxygen reacts with the hand warmer. And the rust in return generates energy, small amounts of energy, which then build up and create the heat that you feel. The vermiculite acts as a sort of moderator for the water, so it doesn't overflow or overtake the packet. And the charcoal acts as the agent that basically disperses the heat throughout the whole package and doesn't just focus it all in one spot, just to prevent like burns, as well as the outer packaging getting destroyed. And some more facts about the science are: a hand warmer heating up represents an exothermic reaction because energy from the rust and oxidation is exiting and emitting from the hand warmer. It's just basically what that warmth you feel is. And the oxygen bonds are first broken and then repaired after reacting with the iron. And once the rust is formed, then that is when you begin to feel the heat emitting from the actual packaging and warming up your fingers. And some fun facts about hand warmers are, as you can see on the right, some of them can last up to 10 hours. So when you really think about that, it's like you kind of open it up in the morning, and by like midday or afternoon, it could still be hot. And they only work when exposed to oxygen, at least the reusable or the disposable ones. The oxygen basically acts as it basically causes the rust to form. And the peak temperature that they reach is around 135 to 145 Fahrenheit. This temperature is not random. It is basically the set temperature that the scientists have basically come up with, that basically warms your fingers up but doesn't burn it completely. It's just that perfect sweet spot. And if you've ever used a hand warmer, you would know that it doesn't burn you, but it also provides that warmth that you could still need in the harsh cold. The warmth felt by the hand warmer is potential energy being released, and the reaction can slow down if it is too cold. So say you're in, below freezing temperatures. That could take your 10 hours of heat all the way down to maybe 5 or 6. So Thank you for watching my slideshow video, and have fun exploring the rest of my website.